Charging by induction. This involves transferring charge between two objects without them touching. Right? Conduction, you had to contact the two spheres together. Now there'll be no contact. The addition we have is this wire here that goes to ground. So we have a neutral conducting sphere. Okay, you can add up the pluses and minuses and they'll be the same. 4 pluses, 4 minuses. And it's connected to the ground via a wire. This time we will bring a rod here, and you can see how it's got more negatives than positives, so that's a negatively charged rod. We'll bring it near, but doesn't touch this sphere. You can see the air gap there, hopefully. Electrons within the sphere are repelled by the rod, and they will pass through the wire into the ground. That will leave a net positive charge on the sphere. And the electrons are being pushed down the wire right here down to the ground. While the negatively charged rod, and that's over here, remains near the sphere, we're not going to remove it yet, but we will remove the ground. We'll take the ground out of the equation. Now, no more electrons can move since the sphere is isolated from the ground. It's got the insulator here, and you have all this air over here. Electrons cannot jump the gap between the rod and the sphere, up here, or between the ground and the sphere. The rod is then removed, and you have to get the order correct. You have to remove the ground wire first and then the rod. It is important to note that the charge on the rod remains the same. It is still negative. It has not lost anything. The charge on the sphere is now positive, as it has lost electrons to the Earth that move through this ground wire here. Now, compared to the amount of free electrons already in the Earth, it has gained a totally insignificant amount of charge. But it still has gained some, right? Because that charge had to go somewhere. It went into the ground. Summarizing the two different ways of transferring charge. We first did conduction, and what was required there was a physical contact. A charged object will transfer a portion of its charge to a neutral object. Because of the conservation of charge, the amount of charge on the initially charged object will decrease, and that charge is picked up by the other object. For example, a positively charged object will transfer positive charge to a neutral object. That will leave it with a net positive charge. The amount of positive charge on the initial object will decrease, right, as some of the charge went to the other object. In the same way, a negatively charged object will transfer negative charge to a neutral object. Induction summary. A charged object is brought close to a neutral object but does not touch it. That's the key. Another key is the neutral object is grounded. It has an electrical conducting path to ground. The charged object, when it's near the neutral one, will repel similar charges on that neutral object to the ground through the grounding wire. Thus, the neutral object is left with a charge opposite to the initially charged object. The initial object does not lose any charge. The extra charge picked up comes from the ground. As long as the ground is disconnected before the initial object is removed, the neutral object will gain charge and it will be opposite polarity to the charging object. If the ground was left in place as initially a charged object was removed, the neutral object would pass its gained charge back to the ground or suck up electrons that it lost depending on what the polarity of the charged object was, and then it would be neutral again. So another key to this is you have to take the ground wire away before you remove the charged object.